In this video, we're going to learn how to draw line structures of organic compounds. Now, in a previous video, we talked about how to change the line structures rather to their condensed structural form. Now, in this video, we'll talk about how to change the condensed structural formula to line structures. Now, here is one example. So let us say you were given this structure and you were required to write or draw the line structure of it. How is it going to look? So this is going to look this way. You could actually decide to draw it this way or like this. Both ways are pretty much the same. Now at this position, there is a CH3 group, which is a CH3, which you see at that position. And on this other side, there is also another CH3 group, which you see there. And at this position, there is a CH2 group. Now, what you need to know in order to always decipher the positions of the carbon atoms and the number of hydrogens that there will be at those positions, you need to know that the carbon atom is tetravalent. What that means is the carbon atom would always need 4 bonds in order to reach its octet. So in that case, if you are able to figure out the number of bonds that there is already within a structure, a line structure, then you just need to think of the remaining number of bonds that carbon atom would need to reach its 4th. So let us consider the middle one, for instance. So we know in this direction, that is 1 bond. And in this direction, that is the 2nd bond. So there is already 2 visible bonds that we can see stretching outwards away from that middle carbon. Now, since we know that the carbon atom needs 4 bonds, there is got to be 2 more bonds. And these are hydrocarbons. So in that case, 2 more hydrogen atoms need to come in to play. And so that would create the 4 bonds. So there is going to be 1 bond here and another one on the other side. So those are the 4 bonds that you can see there. So each bond needs to have a species connected to it. And if you already have the 2 carbon atoms or 3 already creating 3 or 2 bonds, then you just need to figure out what is the remaining number of hydrogen atoms that would complete the tetravalency for the carbon atoms. So if you have an idea of this, you would always be able to draw the structures or decipher which element is at various positions. Now, you also need to know that for hydrocarbons, you just have hydrogen atoms and the carbon atoms. Wherever you need to show any other atom other than these 2, you just need to write it physically. You don't gotta hide it like we're doing here. These ones only occur for hydrogens and carbons. Here is another one. How about this one? Feel free to pause the video, try doing it yourself. So this is going to look like this. Could draw it that way or this other way. Now at this position, there is a terminal and there is another terminal right there. It's the same thing for this part. That is a terminal. This is also a terminal. Now these positions which you see here, those are positions that contain carbon atoms carrying 2 hydrogens each. That is because we already got 2 bonds visibly represented there, stretching outwards out of those carbon atoms. So this carbon atom really just needs 2 more hydrogen atoms. And that is pretty much similar to what this other one needs. So whichever way you draw it, there is actually not going to be no problem. You choose the direction you need. Sometimes you might just really want to use this method because of the substituents that might be present within a compound. So that's really just it. Now here is another one. So what is going to be the line structure for this compound? How can you draw it? Now, wherever you see a bracket that contains any group at all, as far as the stuff which situated within the bracket is a carbon and hydrogens, no matter how many atoms there is around the carbon atoms or the hydrogens. You just need to know, therefore, that that is a substituent. And of course, if you are actually moving in this direction, that means the carbon atom immediately before that stuff represented in the bracket, that will be the carbon that contains what is within the bracket. So in this case, the C, which is connected to one hydrogen atom there, that is what has the CH3 group. So this is how stuff is going to look. First of all, we need to take the total number of carbon atoms present within the parent chain. So this is the first, this is the second, and this is going to be the third. So we have 3 carbon atoms, and there is one CH3 group which would serve as a substituent. So I'm just going to write it this way. At the middle part, we got this, right? So you could just write it from the top down like this, or someone else could just decide to write it this way. And that is the same, basically the same. There is no difference. Here is another one. What is going to be the line form for this condensed structure? So here now we have a CH3 group on one side. There is the CH next to it, and there is a drop down CH3. So in this case, you actually have a choice of writing it or drawing it in whichever direction of your choice. So what I'm going to do, I'm just going to show it this way. So let us say this part contains the CH3 group, which is there. That is this one. And then I'm just going to have the C dropping down with a CH3. So this is going to be the CH3 group. And the NH2 just goes in this direction. So this is what we're going to have, and I'm just going to write the NH2 right there. So NH2 is the hetero group, or the different group apart from the hydrocarbons, which we actually talked about. And this is the CH3 group, which is on the left part. And this is the drop down CH3. This is the CH, which stands in the middle. And that's basically it. This part is actually called an iso unit. So let's just briefly talk about that. How would you be able to identify what an iso alkyl group is? So an iso alkyl group you could have an iso propyl, an isobutyl, an isopentyl, and so on. But the smallest unit of the isoalkyl group is the isopropyl. So how does it look? So let us start with it, the isopropyl. So we need to have a CH3 group. And then that will be connected to a CH group. That CH group in turn has a CH3 group as a drop down, there is going to be a bond that will get connected to whichever group that is coming in, basically, whichever group at all.